Welcome to Whitespace, DCD's weekly look at news from the world of data centers. With this week, two special guests, Ed Ansett and our CEO, George Rocket.
I feel special already.
You've always been special. So, Ed, you're here to tell us about a fairly serious security threat. And when I say serious, you do sound genuinely worried about this one.
I'm so worried about it, yeah. I mean, I came across this problem initially about 18 months ago when we were doing an audit of a data center which was national critical infrastructure, and discovered a wireless gateway in a cooling system. And thought, well, hang on a minute, how secure is that? Only to find out that that wireless gateway could relatively easily could be maliciously hacked into and shut the cooling system down at any time without any notice, and nobody would know, in all probability, who did it. So my initial reaction to that was, well, this can't be true. You know, what's going on? And started looking into it and found that the entire industrial control systems community had been aware of those type of threats and been dealing with those type of threats for over 10 years. In fact, there's an organisation set up by Homeland Security called US-CERT, Industrial Control Systems, Cyber Emergency Response Team, which basically is a central repository for all of the vulnerabilities associated with equipment in control systems, typically affecting national critical infrastructure, so things like power stations, water pumping stations, process plant, all of those kind of things, where the vulnerabilities were known and were being disseminated to the wider community. And this is a massive thing. It's been existing for some time.
I mean, so what we're saying is these are all the control systems that are the operational technology control systems in the data center. The stuff that IT doesn't really understand.
Exactly. It's not just control.
Care about.
It's not just control. The myth is people think that, on the engineering side, the mechanical and electrical systems, don't worry, because we're only monitoring for the most part, we're not doing control. Monitoring systems are just as vulnerable to attack, DDoS, distributed denial of service attacks, and other types of attack as
Yes, I mean, if you turned off the monitoring system, you could engineer it so that the data center would overheat.
Well,
something like that.
Well, typically, I mean, if you take a DDoS attack on a monitoring device, for example, what you do is flood it with information. So you flood the network and stop the entire network from working.
Okay.
In other words, the broader network, whether that's BACnet or Modbus.
Yes.
So that was one thing. So that was the external side of things. We've got a wireless gateway that's inside the chiller control panel, which could be controlled from outside of the data center.
Yes, and you're absolutely right.
That's only one part.
We knew there were dangers in industrial control systems. The insecurity of SCADA had been written up fairly well. We knew about the Stuxnet attack. But I had always assumed that because these data centers came under the category of IT, and IT people understood security, that all necessary fixes would have been applied.
Well, you think so, wouldn't you?
Yeah,
this is the weirdest thing. This is the weirdest thing. That I think everybody thinks that. But what the problem essentially is that the existence of these threats and vulnerabilities in terms of the industrial control systems community is relatively well known. Those systems are used throughout data centers. Every data center contains at least one of those systems. And most importantly is that the protocols that those systems use to communicate with each other, for the most part, were written way before cybersecurity was a threat. And they are all, so I'm talking about Modbus, and BACnet primarily, but SNMP from a power systems point of view particularly, they are all either or have very weak passwords or no passwords, or very weak or no encryption. So what that means is, unlike traditional IT systems where the focus has been on they understand the idea of external attack and internal attack, and there's a lot of focus on how to deal with internal attack. Once you're inside the secure perimeter, the so-called electronic secure perimeter of a data center, if you know what you're doing, you can cause havoc.
So we're working on the London conference, Zetas Structure, and we are looking at this notion of IT people versus OT people, operational technology, that is the systems that connect to the mechanical and electrical parts of any infrastructure, things that make things work. And we're working on that. It's really interesting. And a few weeks ago we were in Madrid and we were with a guy called Massimiliano Facinelli, and he's the head of security of the International Atomic Agency, and he was talking about this, and he went on stage and he showed what he'd been doing the evening before to an audience, about 300 people, and he went through and just showed all the systems that he could hack, he could get into, how he'd found them, and how all the passwords were just the reset passwords because nobody had changed them, and basically showed up on the screen what he could take down and what he could do. And he said, not an idiot could do it, but somebody with a little bit of knowledge and a bit of time could do this. So, how widespread is this?
Well, okay, great. So I'm glad you asked that. So first of all, there's no data yet in terms of an empirical study in terms of the extent of the threat to data centers.
Okay.
There was a great piece of research done in the US using Shodan called Shine. I think it was done by a company called Infracritical. And in that they were looking at the vulnerabilities, external vulnerabilities, in other words, internet-facing vulnerabilities. This study was done, I think it was completed in 2014. Of the first batch, from memory, of the first batch of 500,000 ICS devices found using this the search engine called Shodan.
Sorry, what's an ISCS device?
Industrial control system.
Okay,
so it could be anything from a power plant to a variable speed drive or a data center UPS. It could be anything. It doesn't really distinguish. You have to distinguish by investigation. But the point is, of the first 500,000 that it showed, and there were 2 million in total, something like over 7,000 were reported to ICS-CERT as affecting national critical infrastructure. That's staggering. Now that is an industry that is already 10 years ahead of the data center industry, when I say that in terms of the control systems within data centers. So to me, it's alarming. And I think I said, or maybe I didn't, I was very concerned initially when we discovered the problem 18 months ago by talking about this, just to highlight it. But the reality is the problem is here, and we need to not only highlight it, but also explain to people how we fix it.
But you're an engineer, right, with a big E,
yeah.
And you've been working on all sorts of infrastructure for a couple of decades.
Thanks for reminding me.
It means you're an expert. Were you ever aware when you were building systems of this? This was something that was learnt in engineering degrees? Was this,
no,
the security aspect?
That's why this isn't intuitive to people.
Okay, right.
People won't get this. People are listening to this are going to go, no, this isn't a big deal. Because it's not intuitive. It wasn't a problem at the time. It's something that, the problem didn't exist until, cybersecurity became an issue. And to that point, as I said, we don't know the extent of the problem. But it's significant.
If data centers are all vulnerable in this way...
I'm not saying that.
But,
I'm saying some are.
So, okay, yeah. But if there's a widespread problem of data centers being vulnerable in this way, why aren't we hearing about more of them being attacked with this sort
Well, that's a great question that somebody else asked me. Well, first of all, let me just say this. The widely held misconception by most data center operators is they are air-gapped, okay? Which means that they essentially think they are not connected to the internet.
How does that work, this air gap?
Well,
what does that mean?
Well, in principle, from a control systems point of view, what that means is you are not connected in any way to the internet, okay? That isn't the case.
Right.
Wi-Fi
is so cheap and easy. People bundle it with everything you get,
yeah.
And if you're not careful, it's going to be on by default.
Well, there is that. I mean, there's the other thing is that typically what happens if you take a data center to be quite primitive in terms of control, really, compared to industrial control systems. They use BMS. Some of them use SCADA systems for power systems control. And the basic mantra is, if it's a critical system, do not connect it to a public network at all,
right.
Especially the internet, or any other type of privately owned network. But that's not practical. That's not practical. You cannot, well, you could completely air gap, and that would be the safest thing from an external attack point of view. and there's another thing to say. There's conflicting research. Okay, some of the big research firms have been saying recently, from an IT security standpoint, that the majority of attacks take place from within the electronic perimeter. In other words, the firewall or whatever the electronic perimeter is.
Yeah.
However, the research that we've been doing recently, and other research corroborates this, is that from a data center point of view, it would appear that it's the opposite. That at this stage, anyway, the data centers are. And why isn't it being reported? Well, why do you think, Peter? Can you think of a data center project where you've been involved with, I've been involved with ever, where there wasn't a non-disclosure agreement? You can't report it.
Yeah.
So unless it finds its way into the public domain, it's not going to be reported.
Or unless the failure is obvious that the service goes down,
yeah,
and you never hear why.
Well, there's been plenty of instances of
mysterious
data centers. Yeah, exactly. Data centers going down. You know, there was a fault. My favourite is there was a technical fault.
Yes.
You know, that's a good one. I mean, you know, this is happening. I cannot say whether this is a massive problem or a relatively minor problem, but my senses tell me, until we've got a complete inventory of all of the data centers out there, and their attack surfaces, both externally and internally, we really won't know.
So before you have denial of service attacks on websites, you're attacking an individual company, you're bringing down their website, you're stopping transactions, and IT's got a plethora of different armaments against this and walls that they build up. But I guess the scary thing with this is you're attacking the core, you're attacking the whole building, you're attacking the entire ecosystem in one go if you bring down, if you allow data center to overheat, or if you attack the electrical system. So that's pretty scary, isn't it?
So I mean, to put people's mind at ease, right? I do not believe that your average script kiddie is going to be able to typically, cause massive disruption. Breaking in externally is one thing, breaking internally is a completely different thing.
Okay.
But with a combination of the attack techniques and some knowledge of how to reprogram Modbus, SMP, and BACnet, you can effectively take control of the data center, and you can disrupt it, and you can stop it working completely, and you can do a whole bunch of things.
Is there a bit of irony here that one of the things that might be helping ameliorate the attack is the fact that the attackers need to have the same kind of cross-disciplinary skills, the lack of which inside the data center created the vulnerability in the first place?
That's true. Yeah.
Right. I think we want to move on to ask, well, I certainly want to know what we can do to prevent this kind of attack, and probably also where we might go to find out more. So, what do we do about it?
Okay, so in the very first instance, the first thing to understand is to what extent are you exposed to this type of attack? And it will be mandated eventually. We will be forced to do this by governments, but I think in the first instance, anybody that's interested in self-preservation will want to do this, is find out what your attack surfaces are, both internally and externally. Once those are understood, then we can put in place a strategy to help. You can never completely defend against attack, but to put in place a strategy which will allow organisations to defend themselves. And so the first thing you would do is secure the electronic perimeter. That's the number one thing.
So sort of audit all the non-IT equipment you've got and check it out for network connections.
Well, in fact, you don't need to ignore it, because I can safely tell you now, if you've got a UPS system, and if you've got a BBS system, if you've got a SCADA system, you've got a problem.
Right.
You've got a problem. They're vulnerable if they're using those protocols. What I mean is the external perimeter. Right. The firewall or whatever it is, or whatever means there is of getting through into the data center has to be examined. And that needs to be addressed. Reperimeterization.
Down to physically walking around with a Wi-Fi scanner.
Well, and also having a good look physically at what is there.
So
then put in place, as I say, the right type of technology to. It could be as simple as people doing stupid things. That happens a lot. It's well known. People use, you mentioned earlier, default passwords. They don't update code. They don't, these type of things, basic stuff. And then the next thing is then to look internally. Internally, it's a little bit more complex in the sense that there are only a few technologies out there which are, in our opinion, capable of dealing with the inadequacies, the protocol inadequacies that I talked about earlier. So that's one way of doing it. In the end game, and this is probably one of the big takeaways from this, is that I know that some of the big OEMs right now are in the process of trying to rewrite protocols to make them more secure. Okay,
What, private protocols or?
Well, this is the thing, proprietary protocols, okay? So the thing is, what the kind of call to action for the industry here is what we need is an open source protocol.
Right.
Right, not a protocol written by one company that only works with that company's equipment, because the vast majority of data centers don't use one company's equipment.
Wow, that's quite a tall order, because the industry is only coming to terms with open source hardware. It's driven by IT people, and we're talking there's an operational technology issue here.
I accept it's some years away. So in the first instance, I was going back to how do we fix it? Okay, so after dealing with the perimeter and looking at the internal things, there's a number of things that can be done. And don't get me wrong, the ICS community and manufacturers of this equipment for the ICS community, which, as I say, affects the data center community, are hot on this subject. They know all about it. If you go to some of their websites, you will find long lists of vulnerable devices and patches and suggestions about what you can do about these vulnerabilities. So it's a question of looking at each issue on its own merit and saying, right, this is how we're going to fix this until a more secure protocol comes along.
I guess contrary to the IT world, where you're constantly patching software, you're upgrading every 1 to 2 to 3 years your hardware. Data centers have things that are 15 years old.
Oh, exactly right.
You know,
so that's another point. Okay, so
can they be patched?
The existing protocols that we use, the contemporary protocols are vulnerable.
Okay.
Okay. So the stuff that's being deployed right now, today, and for the foreseeable future, is going to remain vulnerable until we get this kind of universal agreement, if we ever get it, in terms of hopefully some kind of open source protocol which everyone can adopt, that is more secure and can be updated. I don't know when that's going to come about. So, but in the meantime, we've got a mixture of old and new data centers, and the common denominator is they're all using these protocols. So, it's a question, as I say, go back, go in, see what we've got, and let's fix it. Each item, and then and this is going to become policy. It's not just a one-off fix. You've got to keep it updated and have some kind of a proper policy as an organisation for dealing not only with IT cybersecurity, but the data center infrastructure side of things.
This is just a data center, though, isn't it? You're talking about the data center, which is your ground. What about the industrial IoT? What about the Internet of Everything?
Well,
that gets scary.
Well, you said at the beginning I was a data center expert of some decades, right? You said, so that's why I'm talking to you about data centers. But you're right. This is much, much bigger than the data center issue. It's the whole Internet of Things. This problem, I mean, if you look at the amount of devices, addressable devices that are being added to the internet every day, especially with with 5G coming along, goodness knows everything going open source, and we're just going to see more and more and more connected devices. So the need to solve the problem in a broader context goes way beyond data centers.
Yeah.
Yes, I mean you can't secure the Internet of Things by shutting down the communications, because communication is the whole point of it.
Exactly. So yeah.
Okay, so where do we go to find out more?
I wonder.
By magic. No, seriously. This is a big topic at our London event this year, which is our flagship, the DatacenterDynamics London event, and it's entitled the Zetas Structure. We wanted a word which went more than infrastructure, that connected everything. We're entering the zettabyte era, so the Zetas Structure seemed fit for this. I think already committed we have the CEO of a company called Indegy from Israel coming over, that's looking precisely at how they're securing national critical infrastructure. They've been working with energy plants, water systems around the world, and their tech comes from the military. We've got the head of security of the International Atomic Agency. Ed will be joining the Merry Band. We're going to be doing workshops. We've got some keynotes looking at this. So I think this is going to be a massive topic everywhere over the next 12 months. It's probably, it's going to carry on.
This
It's
is
a big one.
This is very reminds me a little bit of Y2K. And people are very critical about that. Say, what's that all about? What was that all about? Why did we spend so much money? Nothing really happened. And we'll never know because people did then spend the money and we don't know. The difference is, unlike Y2K, which comes along once a millennia, probably the only one we'll see, this is here to stay. So it's not just a question of fixing it, it's a question of then maintaining a high degree of awareness and hardening continuously. But what is going to happen is there is going to be a massive wave of activity when everybody wakes up to this. And I know some very, very well informed and top guys in the industry that I've spoken to that were first of all very sceptical about this and have now gone, okay, I get it. This is big. This is really
when
big.
people twig on this, they kind of like get it. There's nothing better than seeing something live in action.
But that's right. I mean, as I said, it's not intuitive for many people. That's why penny hasn't dropped.
You can see it live on someone's Nest device at their home, and then you start getting the understanding that it's on the internet. Nobody secured it. Someone's dimming your lights, but that's that's not a big.
But what I'm worried, what I'm
cycle.
worried about seriously, and this kind of in a way linked into that non-profit group that was starting shortly called DCERT, Data Center Incident Reporting Program. I mentioned that to you before. Is and I think you get this. Years and years ago, data centers failed. Typically, people lost money, and less frankly, governments and the public at large weren't too concerned about that. Now, as our society becomes increasingly dependent on our world, our data center world, we will have much more serious consequences than people losing, a bit of money. So
this is national.
This is big, and it's just going to become more and more so.
Okay, and so the kind of discussion that we're hoping for is to first of all get information out so people who've got data centers can harden them and resist this. We need sort of vendors and suppliers and OEMs to start building security in as the facilities are built and as the products get shipped, and some sort of agreement across the industry of how to lock it down.
Well, I think the very first thing is there's all of that, but the first thing that needs to be done is everybody needs to understand, am I vulnerable? The answer is going to be yes, but the question is how vulnerable. And then the second question is, who's going to fix this for me?
Okay, brilliant. Thank you for telling us all about that.
Okay.
Yeah, sweet.
I'm more worried now than I was before.